Hello everybody and welcome to another video on Code Learning Central. Today we're going to be doing another video on C. It's going to be a little bit simpler today. I'm not going to be throwing as much at you. We're not going to be doing top-down design on this one. But today we are going to be doing something that is involving advanced mathematics. So, we need to find the factorial of a number and it needs to be the approximate value. So, what we're going to be using is what is called Gosper's approximation formula. And I will show you right here what that is. So looking at this formula, we are saying that the factorial of n, the number that we're going to provide, is approximately equal to n to the nth power times e, Euler's number, to the negative nth power times the square root of 2 times n plus 1/3 times pi. So this looks like a lot being thrown at you, but don't worry, because what we're going to do is break this down into sections so we are able to A, easily understand what we're doing, and B, easily debug the program if there's issues with it. So, first starting out, let's go back to our code and just begin setting up what we need in order to get started. First thing we're going to do, of course, is include our libraries that are needed in order to get our program functioning and get everything in terms of predefiners and our operatives that we need. So, I explained before in my previous video what all of these do. Um, Using the math library again in order to get some easy functions out of it to help us simplify a lot of our math that we're going to be doing. And after that, what we're going to do is introduce you to constant variables. So, as we know, that in our formula we have pi, which pi is a constant in mathematics, meaning that it is always going to be the same, and it even has its own symbol, being the pi symbol. So, in order to have a constant in our program, we do what is called a definition of a constant variable. So it would be pound define, and then after you put define, you want to put your variable name. Notice that we're not putting an equal sign after we do our variable declaration because it is not needed for a constant definition. So we'll go ahead and put in the approximate value pi, and then we are done with that declaration. Now we are telling the C compiler that we do not want this to be changed whatsoever. Continuing on with the program, this is going to stay the same and it cannot be manipulated. If you try to manipulate it, it's not going to work. So, we'll go ahead, create the shell of our main function just to get it out of the way. And in my previous video, I explained why we are doing these things right here, what is going on with that. Now, after we do that, let's go ahead and make a prototype for our function that we're going to be using. So, again, I've said in previous videos, you do not have to use functions most of the time in order to get what you need out of a program. But it just makes it a lot easier when you're looking into the main function in order to have a simpler look at what's going on, because you can just reference back to functions instead of trying to look at all of the data inside the main function in order to see what's going on with your program. So let's go ahead and define this prototype as Gosper's formula, because that is the formula we're using. We're using Gosper's approximation formula in order to do this calculation. And we want to say we're returning a double value, and we want an argument of the number that we're putting in. Now the number will be an integer, but for our calculation purposes, we're going to go ahead and just make it a double so we don't have to convert it later or have any problems with accuracy in our calculations. So after we do that, we'll go ahead and copy this, and we'll get to work on our function. So, starting here with the curly brackets containing all of our functions data. Now, we want to break this up into sections because this is a very large formula. So I can already see about maybe 4 or 5 sections that we can break this up into. And I'll show you what I'm talking about. So this right here, the product of these two exponents, could definitely be its own section. This right here, this sum of these two, can definitely be its own section. And then the product of these two can be its own section. And then the square root can be its own section. And then the product of these two groups can be its own section. So, as I said, breaking this down to section will A, make it easier for you to go through the process of a formula, and B, make it a lot easier to debug if you have any accuracy issues in your output results. The big thing that I'll be showing you is printing results that you're getting throughout the calculation, so then you can pinpoint exactly where your program's making a mistake if it's making a mistake. So we'll go ahead and go back to our code and begin writing. So first thing we're going to do, like I said, is we're going to want to put in sections for our calculations. So I'll say section 1, section 2, section 3, section 4, and section 5. And what we're doing here is just doing some pre-definitions so we can get in there and take out every section one at a time and be able to cross them off our list as we go. Now, another thing to take into consideration is we have Euler's number right here. This is another constant in mathematics that is approximately a number just like pi. It's very big, it's an irrational number, so it goes on forever. But in this case, we're just going to go ahead and take its simple form, just like they do in defining pi. I'm going to say E equals this number right here. Big, long number. Now that we got that out of the way, we can now start plugging in equations. So, for section 1, what we're going to do is we're going to go in and we're going to say that we want to get this part out of the way. I'll put it in red for you so you can see it better. We want to get this out of the way. We want to get n to the nth power times e to the negative nth power done and over with so we don't have to deal with it anymore. So, go ahead and go back to our code. And what we'll do is we'll say pow, n as our base, n as our exponent, and we want to multiply that by pow, e as our base, and negative n as our exponent. Now, as previously stated in my last video, pow is used to do exponential calculations with first number being your base and the second number being the exponent. So this right here is no different than this right here. It's just in a way that C can understand it, but there is no difference whatsoever. So we got section 1 out of the way. We can, if we want, let's not cross it out, but let's go ahead and just take blue and underline it so we can say we got this problem out of the way. This is done and over with. So now that we got that finished, we can go ahead and move on to the next section of our equation. So section 2 equals 2 times n plus 1 divided by 3. Now, notice here that I am making these decimals. Why am I doing that? That is because we made section 2 a double variable. So, in order to take out any possibility of an inaccuracy or an inability to make a calculation, anytime we define a variable as a double, make sure you make any calculations with numbers. All those numbers are doubles. So, you know, 1.0 is no different than 1, but to the C compiler, it's sometimes not going to understand when you just put integer values in there. It's going to take it as ints, and it's saying, hey, I'm a double variable, I can't do ints, and it might just not do the calculation you want, and you might get inaccurate results. So that is why we're doing that right there, and just to keep that in mind for you. So after we do that, we can say, let's go ahead and get that out of the way. We don't need that. So we'll go ahead and say we got this part done. This part right here is finished, and we don't need to do it anymore. Now we're going to go ahead and go on to taking the product of this right here and this guy, pi. So going back to our code, we're going to go in here and say section 3 equals section 2 times pi. Now, what did we just do here? We said we want section 2, which equals this right here. Take that times pi, which we go back to our formula. I'm doing this right here. So we got this out of the way. It's done and over with. Now, as previously stated in my last video, I talked about local variables and how variables outside of a function cannot be used within a function unless they are in arguments. Now, when it comes to pi right here, pi is a constant, meaning pi can be used anywhere. A constant defined variable can be used at any time and any place in your program. So keep that in mind, that if you want a variable to be global, you can make it a constant variable, but the disadvantage is you cannot manipulate it. You cannot change its value. You can make a variable that takes on its value, and then you can manipulate that variable, but you cannot manipulate the variable itself to have a different value. So, just want to go over that with you guys, and we'll go ahead and do our next section, section 4. Section 4 will say we want the square root of section 3. Not section 5, section 3. Now, square root, this comes from the math library, and it's just taking the square root of whatever value that you put within the parentheses here. So, we go back to our formula again. Now we've got the square root out of the way. We're done with the square root here. And as you can see, both of these sections are finished. Now we just need to get the product of these two. So, we can go back to our code. Let's say section 5 equals section 1 times section 4. Now, we have completed our formula because we broke it down into sections, and now we got two groups here, this group and this one, and we took both of these groups and multiplied them by each other and was able to get the final answer to plug back in to here. So we'll go ahead, back to our code, return the value that we just got, and we'll go up here and we will prompt the user to put in a number. So we'll say printf, enter the number that you want to calculate the approximate factorial for. Go ahead and put an arrow here to make it easier for the user to read. Go ahead and put a new line in here so we can get some space between our power or command prompt command in order to load the program. Go ahead and do a scanf, %sign LF. I'm going to go ahead and point that back to number. And we need to define that because we have not defined that yet. So we'll say double number. Now, after it does scanning that, we need to go ahead and define another variable in order to get our function call. So we'll just call this calculation, and we'll say calculation equals Gosper's formula, and the argument will be the number that is provided to us. And now we will go ahead again, and I did this before in our last video. When we get the number, it's going to want to display it as a double, which we don't really need to do that, so we'll say display number. And as I've said before, there's probably other ways you can do this, but in order to just get this without any bugs and make it easier for you to understand, we'll just make a new variable. Won't hurt anything. So after doing that, what it'll do is it'll cut off the decimals that are provided, making that original variable a double, and we'll display the value. So say new line, the approximate factorial for %sign D exclamation point is %sign LF. Now we'll go ahead and we'll say we'll just say %sign D is approximately %sign LF. Make this shorter and sweeter. And we'll go ahead and put display number and calculation as our last two arguments. So now we make sure to save this and just go ahead and look at the program again, make sure that everything is in order, looking good. Everything should be correct. So now what we'll do is we'll go ahead and go to our command prompt and make a executable for this. So gcc/o, we're telling the GNU-C compiler we want to make a new executable file. So YouTube Gosper's formula.exe, and our C file that we want to use is YouTube Gosper's formula.c. So everything's good there. So it's a YouTube Gosper's formula. So now we go ahead and put in 5 as our number, and we do have an issue here. So our issue, we'll go ahead and look at that and see what we did wrong. And what did I do? As usual, I forgot to put the ampersand as the pointer. So we'll go back and look at my program. Look at this right here. Very important that you put the ampersand to your pointer. And this is actually a good lesson in order to teach you guys what is happening when I don't do that. So, an ampersand is declaring a pointer. what is a pointer? A pointer is basically, as it's stated, it's pointing back to an original variable and giving it whatever new value that you get from the scanf in this case. So what we're saying is we want to get the input of the user, and we want to say, hey, I got this value that the user inputted. Now, I want to take this value and put it back up here into this variable's assigned value. And then it will save that assigned value for later use. Now, what it just did there with that error is it doesn't have a value yet for number. We didn't assign it any value. So when we try to put in number inside of our function, it's not going to compute because there is no assigned value to that, and it's just going to think it's null. There is no value. It's not zero, it's just nothing. So it's going to, kind of have an issue in terms of doing what it needs to do. So we'll go ahead and run it again, and it should work this time. So go ahead here and just make it again. Now we want to get the factorial for 5, and our answer comes out to 119.970030. And this is the correct answer for the 5 factorial using Gosper's formula. So, just to review again, what we did today, we took this formula here. It's a little bit messed up now. We'll go ahead and Control Z our way back to its original state. So we took this formula here and we broke it down into sections in order to get what we need out of it. We put it in our C program, asked the user for input, gave us the number 5, did our calculations here in our function, and then displayed an output of what the approximate factorial value of that number is. So, to reiterate again, we use the math library, and we define pi as a constant function, or constant variable, sorry. Now this right here, yes, we probably could have made a constant, but in order to get what we need out of it, we just went ahead and just made it a predefined variable. It doesn't really matter. We weren't manipulating in any way, really, but technically, yes, we could have made that a constant variable at the beginning of our program. So, I think that just about covers it for today. I hope you guys learned something from this. Let me know in the comments if you want any help, if you have any suggestions on future videos, or if you have any criticisms. I'm open to anything in that regards to improve the channel and improve when bringing to you the viewers. So, hope you guys have a great day, and thank you for watching.